Okay, number one. All right, now listen carefully what we're going to do. So here's the problem. We have the square root of x squared y to the fifth. X squared y to the fifth. Now here's how we would do this. I would think about it this way. So I'm going to use the product property. I'm going to rewrite this as the square root of x squared times the square root of y to the fifth. Okay? And then remember the index is 2. Now if the index is 2 and the exponent's even, that's an easy kind. Because remember, the square root of x squared is x because x times x is x squared. 2 divided by 2 is 1. But here's the problem here. If we look at the square root of y to the fifth, that's not a nice one because there is no expression times itself. That is y to the fifth. Because think about it, y squared times y squared is not y to the fifth. Y cubed times y cubed is not y to the fifth. Okay? So you got to think about this in a different way. Now here's the way you want to think about this, and it helps. Think about it this way. Since the index is 2, you want to find an exponent that's divisible by 2, right? So here's how you can think about this. So I'm going to rewrite the square root of y to the fifth right here. All right, now listen carefully. What is the largest integer less than 5 that's divisible by 2? And the answer is 4. You must say 4. 4 is the largest integer less than 5 that's divisible by 2. So I can write this as the square root of y to the fourth times the square root of y. And now you know what this is. What times itself is y to the fourth? Y squared. And I cannot simplify this. Now let me remind you, or let me tell you why you cannot simplify this. Look at the exponent. The exponent is 1. If the exponent is less than the index, you're done. If the exponent of the variable is less than the index, it cannot be simplified. Can't be simplified. The radical cannot be simplified. So can I simplify the square root of y? The answer is no, because the exponent is 1. 1 is less than 2. Okay? So this right here becomes y squared square root of y. And that goes here. So this right here is times y squared square root of y. And so the answer is going to be x y squared square root of y. That's your answer. The more you do with this, the easier it becomes. But you got to think about this approach right here. Okay? Now, always check yourself. 5 divided by 2. 5 divided by 2. So let's think about this. 5 divided by 2 as a mixed number is 2.5, right? So this 2 that you see here is this exponent right here. That must always match. 2, 2. That numerator right here, that 1, that is this right here. That's that exponent. That denominator, so let me write that right here. That's the exponent. That denominator, that's the index. What's the index right here? The index is 2, right? The square root, 1 divided by 2. 1 divided by 2. 1 divided by 2. It helps if you know all this different thought processes as you go through these. All right, so we're going to talk about this again in number 2. So let's go to number 2. All right, number 2, this time I have a cube root this time, of x to the fourth, y to the sixth, z to the eighth. Okay, so I'm going to break it down into products. So this becomes the cube root of x to the fourth times the cube root of y to the sixth times the cube root of z to the eighth. Okay? Now, can I simplify this one? Yes, because the exponent is greater than or equal to the index. So just remember this. You can simplify a radical. You can simplify a radical with with variable expressions in the radicand, with variables in the radicand, if the exponent is greater than or equal to the index. Okay, so the exponent is greater than or equal to the index. So since 4 is greater than or equal to 3, I can go further. But here's the thing though. Is 4 divisible by 3? No. Just like we did here. Is 5 divisible by 2? No. So we have to ask ourselves, since that's a 2, what is the largest integer less than 5 that's divisible by 2? And that was 4. The same thought process here. What's the largest integer less than 4 that's divisible by 3? Okay, the index 3. And the answer is 3. So you're going to rewrite this as the cube root of x cubed times x. Cube root of x cubed times x. When you multiply like bases, you add exponents. 3 plus 1 is 4. 4 plus 1 is 5. This one's easy, right? Because 6 is divisible by 3. So what times itself 3 times is y to the 6th? The answer is y to the 2nd. 6 divided by 3 is 2. Y squared, remember y squared times y squared times y squared is y to the 6th. That's the radicand. When you multiply like bases, you add exponents. 2 plus 2 plus 2 is 6. Let's go to the next one. Can I simplify this? The answer is yes, because 8 is greater than or equal to 3. But is 8 divisible by 3? The answer is no. So now we got to ask ourselves, got to look at this right here. What is the largest integer less than 8 that's divisible by 3? So some of you may say, well, what about 7? No, think about it. 7 divided by 3 is not a whole number. That's a decimal. All right, so then you may say 6. Well, what's 6 divided by 3? It's it's a whole number, right? So yes, the largest integer less than 8 that's divisible by 3 is 6. So now you're going to rewrite this as the cube root of z to the 6th times z. Now be careful. 6 plus what is 8? 6 plus 2, right? So that becomes z squared. When you multiply like bases, you add exponents. 6 plus 2 is 8. All right, now here's what I'm going to do. I'm going to rewrite this as a product of separate radicals. All right, so it's right here. So the cube root of x cubed times the cube root of x times y squared times the cube root of z to the 6th times the cube root of z squared. Okay? All right, now listen. I am going to underline, and it helps, I'm going to underline those radicals that I can simplify now. I can simplify this because 3 is divisible by 3. I cannot simplify this. Remember, if the exponent of the variable is less than the index, it cannot be simplified. 1 is less than 3. I can simplify this, right? 6 is divisible by 3. Can I simplify this? No, because 2 is less than 3. Okay, now ask yourself, what is the cube root of x cubed? 3 divided by 3 is 1. So what's the cube root of x cubed? The answer is x, because x times itself 3 times is x cubed. I'm going to rewrite this. I cannot simplify this, so that's the cube root of x. I'm going to bring y squared down. All right, now listen carefully. I can simplify this. 6 divided by 3 is 2. So the cube root of z to the 6th is z squared, right? Z squared times z squared times z squared is z to the 6th. Can I simplify this? The answer is no. So that's the cube root of z squared. So that's where I'm at. Okay, now, that's not your answer. Okay, so listen to what I'm about to say. You always want to write the answer. See how I have two cube root expressions? You want to write it as one. So remember, there is a property that says this, the product property. Again, you can think of this as a product property as well. All right, if I have the a root of b times the a root of c, so you see the indices are the same. As long as the indices are the same, a root, then I can write this as one radical by just multiplying the radicands together. So that's the a root of b times c. Okay, so you see this right here, cube root, cube root. So I can write this as the cube root of x z squared. You must always write it as one. Don't write them separately. Write it as one. And the rest you're going to put in front. So you're going to say x, y squared, z squared. So x, y squared, z squared times the cube root of x, z squared. That's the answer. The more you do, the easier it becomes. So let's look at another one. So this will be number 3. So the more you do, the more we do, the easier it will become. All right, so this is number 3. We have the fourth root of 16 x to the 5th, y to the 12th. The fourth root of 16 x to the 5th, y to the 12th. So let's go ahead and rewrite this using the product property. So it'll be the fourth root of 16 times the fourth root of x to the 5th times the fourth root of y to the 12th. Okay? Now, look at that 16. Is there, well, first of all, ask yourself, is the fourth root of 16 a whole number? So meaning this, is there some number times itself 4 times that is 16? And the answer is yes. It is 2, right? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So that's 2. So right away we know this is 2. Okay? Now let's look at this one. Can I simplify this radical right here? The answer is yes, because 5 is greater than or equal to 4. But 5 is not divisible by 4, right? So you got to think about this, all right? So I'm going to go off to the side, and I'm going to rewrite it over. The fourth root of x to the 5th. What is the largest whole number, the largest integer, less than 5 that's divisible by 4? The answer is 4. So this becomes the fourth root of x to the 4th times the fourth root of x. Y'all agree? Fourth root of x to the 4th times the fourth root of x. When you multiply like bases, that exponent is 4 plus 1 is 5. But what is this? 4 divided by 4 is 1. So the fourth root of x to the 4th is just x. Can I simplify this? Always ask yourself, can I simplify this? Well, the exponent is 1, the index is 4, so the answer is no, because 1 is less than 4. So this right here is this. So I'm going to put this here. So this right here is this. So that's x, fourth root of x. Okay? All right, now look at this one. Can I simplify the fourth root of y to the 12th? The answer is yes, because 12 is greater than or equal to 4. The only time you cannot simplify is if the exponent is less than the index. But this is a nice one, isn't it? 12 is divisible by 4. So since 12 is divisible by 4, what's 12 divided by 4? 3. So what do you think the fourth root of y to the 12th is? Well, the fourth root of y to the 12th is y to the 3rd. Because y to the 3rd times y to the 3rd times y to the 3rd times y to the 3rd. Remember, y to the 3rd times itself 4. The index is 4. 4 times. When you multiply like bases, you add exponents. 3 plus 3 is 6. 6 plus 6 is 3 is 9. 9 plus 3 is 12. All right? Okay, now, you don't want to write the answer like this, though. Okay? You want to put the radical on the end. Put the radical on the end. So here's how you want to write the answer. 2x, put y cubed next. Notice I'm putting them in alphabetical order. 2xy cubed, and then the radical at the end, the fourth root of x at the end. And there's your answer. That's all you do. Same thought process, same idea as through for each of those problems. Okay, let's look at number 4. Number 4, we have the square root of 125, square root of 125, x to the 8th, y, z to the 7th. So the square root of 125, x to the 8th, y, z to the 7th. Okay, so again, let's use the product rule again. So this would be the square root of 125 times the square root of x to the 8th times the square root of y times the square root of z to the 7th. Okay? All right, let's look at the square root of 125. Is 125 a perfect square? Is there a whole number times itself that's 125? The answer is no. But is there a perfect square that goes into 125? The answer is yes. Let's think about this. 125. Do y'all agree that 25 goes into 125? So if you need to use your calculator, you do that. So 125 divided by 25 is 5. So this becomes the square root of 25 times the square root of 5. 25 times 5 is 125. Okay, now, okay, so the square root of 25 is 5, so you get 5 square root of 5. Okay, so that goes here. So that's 5 square root of 5. Now let's look at this one. Can I simplify the square root of x to the 8th? So notice the reason why I'm writing it like this is so I can ask myself, can I simplify each of these? Can I simplify the square root of x to the 8th? The answer is yes, because 8 is greater than or equal to 2. The index is 2. But this is a nice one because 8 is divisible by 2. 8 divided by 2 is 4, so that's an easy one. That's x to the 4th, right? X to the 4th times x to the 4th. When you multiply like bases, that exponent, that's x to the 8th. Can I simplify the square root of y? The answer is no, because the index is, I'm sorry, the exponent is 1, 1's less than the index. So I'm just going to have to rewrite this over. Now be careful here. I can simplify this one because 7 is greater than or equal to the index, but 7 is not divisible by 2. So let's think about this. Let's go off to the side and do the work. Square root of x, z to the 7th. What is the largest whole number less than 7 that's divisible by 2? The answer is 6. Always use the largest. Use the largest. It helps. It helps if you use the largest. Okay? Multiply bases, you add exponents. So this has to be 6 plus 1 right here is 7. Now I'm going to rewrite this as the square root of z to the 6 times the square root of z. Now what's the square root of z to the 6? 6 divided by 2 is 3, right? So that's z cubed. I cannot simplify this because 1's less than 2, the index, so that's the square root of z. So that goes here now. So this is z cubed times the square root of z. All right. So notice what I did. I did the square root of this, square root of this, square root of this, square root of this. Then I simplified each of those if I could. All right, now don't leave your answer like this because notice square root, square root, square root, right? So if the indices are the same, square root, square root, square root, that means you can write it as one square root. So we're going to put, I'm going to underline the others. So here are the others, the 5, the x to the 4th, z cubed. I'm going to put that in front. 5 x to the 4th, z cubed. And then I'm going to put these as 1 because they're all square roots. So that's going to be the square root of 5y, z. And that's your answer. All right? So it's important you remember that square root, square root, square root, write it as one square root. Just like over here in, let me find it, right here where we had cube root, we wrote it as one cube root. Okay? All right, so that's number 4. Let's look at another one. See, the more you do, the easier it becomes. All right, so number 5. Number 5, let's suppose we had this. Negative 5 times the square root of 18 x to the 6th, y to the 8th, z to the 12th. The square root of 18, negative 5 times the square root of 18, x to the 6th, y to the 8th, z to the 12th. Okay, so let's go ahead and use a product property. So this becomes negative 5 times the square root of 18. So I'm just splitting them apart. Times the square root of x to the 6th, times the square root of y to the 8th, times the square root of z to the 12th. And then we're going to simplify each of these. Square root of 18. 18 is not a perfect square, but let's think about this. The largest perfect square that goes into 18 is 9. So I can write this as the square root of 9 times the square root of 2. 9 times 2 is 18. And the square root of 9 is 3. So that's 3 square root of 2. So that's going to go here, right here. So this is negative 5 times 3 square root of 2 times, okay, now let's look at this. Can I simplify the square root of x to the 6th? You need to say yes, because 6 is divisible by 2. Or rather, you need to say yes because 6 is greater than or equal to 2. But the easy part is that 6 is divisible by 2. 6 divided by 2 is 3. So what is the square root of x to the 6th? It's x to the 3rd. Can I simplify the square root of y to the 8th? Yes, because 8 is greater than or equal to the index. But this is an easy one because 8 is divisible by 2. 8 divided by 2 is 4. So this is y to the 4th. Times z to the 12th. The square root of z to the 12th. 12 divided by 2 is 6. So that's z to the 6th. All right, and then we're going to put the radical on the end. And we're going to say negative 5 times 3 is negative 15. So that's negative 15. X cubed. Then put the y next. And then put the z next. And then the square root of 2. All right, that's the only radical, that's the only square root you see. And that's the answer. So that's number 5. Number 6. Number 6, we have the square root of 20, x to the 5th, y to the 11th, z to the 6th. The square root of 20, x to the 5th, y to the 11th, that's a 11 right here, z to the 6th. Okay, so rewriting this as a product, I'm going to write this as square root of 20 times the square root of x to the 5th times the square root of y to the 11th times the square root of z to the 6th. Okay? Now let's go by the square root of 20. 20 is not a perfect square, but I know that 4 is the largest that goes into 20. So I'm going to rewrite this as the square root of 4 times the square root of 5. 4 times 5 is 20. The square root of 4 is 2. So that's 2 square root of 5. So that goes here now. So 2 square root of 5 times, now let's talk about this. Let's talk about this. So go off to the side. It helps if you go off to the side and do all of this. Square root of x to the 5th. 5 is not divisible by 2, so you got to ask yourself, was the largest whole number less than 5 that's divisible by 2? And the answer is 4. So that would be the square root of x to the 4th times the square root of x, right? Multiply like bases, add exponents. 4 plus 1 is 5. What's the square root of x to the 4th? 4 divided by 2 is 2, so that's x squared. X squared times x squared is x to the 4th. I cannot simplify this because 1 is less than 2. So that goes here now. So that's x squared, square root of x, times, now let's do this one. So you're doing each one at a time. That's how you do this. Okay, let's talk about this one. Square root of y to the 11th. 11 is not divisible by 2. So what's the largest whole number less than 11 that's divisible by 2? The answer is 10. So I'm going to rewrite this as the square root of y to the 10th times the square root of y. Right? 10 plus 1 is 11. And notice, what's the square root of y to the 10th? What times itself is y to the 10th? The answer is y to the 5th. 10 divided by 2 is 5. Can I simplify the square root of y? The answer is no, because 1 is less than 2, the index. So all I can do is just rewrite it. That's a y. So that goes here. So times y to the 5th, square root of y, times, all right, can I simplify the square root of z to the 6th? Yes, because 6 is greater than or equal to the index. But this is an easy one because 6 is divisible by 2. So the square root of z to the 6th is z cubed. 6 divided by 2 is 3. Makes sense because z cubed times z cubed is z to the 6th. All right, now that's not the answer. So what I would do next, if you have to, it sometimes helps, is I would underline all of the square roots. Okay? And then I'm going to write it as 1. I'm going to put it at the end. So everything else I'm going to put in front. So that's going to be 2x squared, y to the 5th, z cubed. 2x squared, y to the 5th, z cubed. And notice everything else is a square root. So I'm going to put the square root of 5xy. 5xy. All right, so that was that one. Number 7, negative 2 times the cube root of negative 48 x to the ninth. Okay, so negative 2 times the cube root of negative 48 x to the ninth. Okay, now that's cube root this time. Okay, so let's go ahead and use the product rule. So that's negative 2 times the cube root of negative 48, okay, times the cube root of x to the ninth. All right, now we're going to simplify each of those radicals. So I have negative 2 times, okay, now let's put this on this side to kind of work it out. So the cube root of negative 48. Now remember, this time we're dealing with cube root. So is there a perfect cube that goes into 48? Remember your perfect cubes. Just kind of find them real quick so that I won't have to rewrite those. So I can't find them. Oh, here, nope. Okay, so I'm just going to go ahead and rewrite them. Your perfect cubes are 1, 8, 2 times itself, 3 times is 8. The next one is 3 cubed, which is 27, and then 4 cubed, 64, and so on. But you see this 8? That goes into 48, doesn't it? So I can rewrite this as the cube root of negative 8 times the cube root of 6. Not negative 6, 6. A negative 8 times a positive 6 is negative 48. But what is the cube root of negative 8? What times itself 3 times is negative 8? The answer is negative 2. So this becomes negative 2 cube root of 6. Don't forget the index. Make sure you put the index. So that goes here. So this negative 2 times, we just found this one. That's this. So the negative 2 cube root of 6. All right, times. All right, now let's look at this one. Can I simplify this radical that has a variable in it? The answer is yes, because 9 is greater than or equal to the index. But this is an easy one, right? Because 9 is divisible by 3. 9 divided by 3 is 3. So that's x cubed. And so now I'm going to put this on the end. So I'm going to have, oh, I'm sorry, negative 2 times negative 2 is a positive 4, sorry. Negative 2 times negative 2 is a positive 4. So I'm going to put the square root of 6, the cube root of 6 on the end. So 4x cubed, cube root of 6. And that's the answer. 4x cubed, negative 2 times negative 2 is 4, x cubed, cube root of 6. All right, let's look at number 8. So the more you do, the easier it becomes. Okay, number 8. Number 8, let's suppose we had this for number 8. Okay, so let's suppose we had this. We had 3x squared, y to the 7th, times the cube root of 8, x to the 4th, y to the 14th. Now don't let that throw you off because you have all these variables on this side. That's okay. All right, we're still gonna, what I would do if you need to is I would just go ahead and kind of cover this part up for right now and only look at this. All right, so if you just take this and put it on this side for right now. So that's the cube root of 8 x to the 4th, y to the 14th. Now using a product property, that becomes the cube root of 8, cube root of x to the 4th, cube root of y to the 14th. Okay, so cover this up if you have to. If that throws you off, cover it up and only deal with this for right now. Okay, what's the cube root of 8? Well, the cube root of 8 is 2. 8's a perfect cube. Can I simplify the cube root of x to the 4th? Yes, because 4 is greater than or equal to the index. But 4 is not divisible by 3. So then we got to think. Let's go ahead and do that here. What is the cube root of x to the fourth then? Well, what's the largest whole number less than 4 that's divisible by 3? The answer is 3. So it'll be the cube root of x cubed times the cube root of x. 3 plus 1 is 4. And now the cube root of x cubed is x, so get x cube root of x. So that goes here. So that's times x cube root of x. Then you do the same thing with this one. Okay, so let's talk about that one. The cube root of y to the 14th. I can simplify this because 14 is greater than or equal to the index. But 14 is not divisible by 3. So I got to think about this. What is the largest whole number less than 14 that's divisible by 3? 13 is not it, right? But what about 12? The answer is 12. So this is the cube root of y to the 12th times the cube root of y squared. 12 plus 2 is 14. So make sure you put the exponent correct here. 12 divided by 3 is 4. So the cube root of y to the 12th is y to the 4th. 12 divided by 3 is 4. Can I simplify the cube root of y squared? Is 2 2 is less than 3, so the answer is no. You cannot simplify that. So just rewrite it over. So that goes here. So that's times this right here, y to the 4th, cube root of y squared. All right, now notice I have all this right here covered up. So still deal with this. So let's put I'm underlining the cube roots, cube root of x, cube root of y squared. So everything else I'm going to put in front. So this piece right here is just 2x y to the 4th times the cube root of x y squared. Now that goes here. Okay, so I'm going to uncover this. So now I'm going to rewrite this little part over. 3x squared y to the 7th, that's a 7, times, all right, we just found what this is. This is this right here. So 2x y to the 4th cube root of xy squared. Okay, now don't leave your answer like this, because you see this right here? I'm covering the cube root. 3 times 2 is 6. X squared times x to the first is x to the third. Y to the 7th times y to the 4th is y to the 11th. Okay? 3 times 2 is 6. X squared times x. So 2 plus 1 is 3. Y to the 7th times y to the 4th. When you multiply like bases, you add exponents. 7 plus 4 is 11. And now you're going to put this right here. Cube root of x y squared. So that's the answer there. So that one was a little bit more complicated, only because of this piece right here. Okay, we can do a couple more, I think. So let's do number 9. Number 9, we have, let's do this one. So there might be a worksheet or a MyMath Lab where you'll see something like this. The square root of z to the 5th divided by 25 y squared. Okay? So you're taking the square root of a fraction. So remember how we wrote this using a product property? The product of each cube root. This would be the quotient. You're dividing, so write as a quotient. So this would be the square root of z to the 5th divided by the square root of 25 y squared. Okay? First thing you would do. Now, let's look at the numerator first. Let's do the numerator for right now. Numerator. The square root of z to the 5th. Can I simplify the square root of z to the 5th? Yes, because 5 is greater than or equal to the index, which is 2. Is 5 divisible by 2? No. So I need to think about this, how I'm going to rewrite this. What's the largest whole number less than 5 that's divisible by 2? The answer is 4. So it'll be the square root of z to the 4th times the square root of z to the 1st. 4 plus 1 is 5. Square root of z to the 4th is z squared. Can I simplify the square root of z? 1 is less than the index, so I cannot simplify it. So that's your numerator. So that goes here now. Z squared square root of z. Okay? Now, cover that part up and look at the denominator. Your denominator now. Square root of 25, y squared. I can rewrite this as the square root of 25 times the square root of y squared. What's the square root of 25? Well, the square root of 25 is 5. What's the square root of y squared? 2 is divisible by 2. That's just 1, so that's just y. So that's your denominator, 5y. And notice that there are no common factors, so there's your answer. That's it. Okay? Number 10. Number 10, let's suppose we had the square root of 9x cubed divided by 16. Square root of 9x cubed divided by 16. So again, same thing. Let's rewrite it as the square root of the numerator, square root of the denominator. So the square root of the numerator, square root of the denominator. Okay, let's look at the numerator. Cover this part up, do each piece individually. So the square root of 9x cubed, I know I can write that as the square root of 9 times the square root of x cubed. Square root of 9, 9 is a perfect square. Square root of 9 is 3. Now let's talk about the square root of x cubed. X cubed. 3 is not divisible by 2. So I got to think about what's the largest whole number less than 3 divisible by 2. And the answer is 2. So it'll be the square root of x squared times the square root of x. The square root of x squared is just x, right? Because x times x is x squared. I cannot simplify the square root of x. So you have to rewrite this. So that goes here. Okay? So the square root of 9x cubed is this. So we put that here. So 3x square root of x. The denominator is easy because 16 is a perfect square. Square root of 16 is 4. And I cannot simplify. There are no factors I can reduce. So there's the answer. All right, let's look at number 11. And number 11, let's suppose we had this for number 11. Let's suppose we had 8 times the square root of 9, x squared y to the 5th, z cubed. 8 times the square root of 9, x squared y to the 5th, z cubed. Okay, so again, let's rewrite this as each square root, as the square root of each of these. So that's 8 times the square root of 9 times the square root of x squared times the square root of y to the 5th times the square root of z cubed. It helps if you do this. It helps. And now let's simplify each of those square roots. So I get 8 times 9 is a perfect square. The square root of 9 is 3. Can I simplify the square root of x squared? Yes, because 2 is greater than or equal to 2. Is this an easy one? Yes, because 2 is divisible by 2. So what's the square root of x squared? 2 divided by 2 is 1. So what's the square root of x squared? It's just x. Can I simplify the square root of y to the 5th? Yes, because 5 is greater than or equal to 2. Is this an easy one? No, because 5 is not divisible by 2. So let's go off to the side. Square root of y to the 5th. What's the largest whole number less than 5 that's divisible by 2? The answer is 4. So it'll be the square root of y to the 4th, square root of y. 4 plus 1 is 5. Square root of y to the 4th, 4 divided by 2 is 2. So it'll be y squared, square root of y. So that goes here now. See, that's what we just found. Y squared, square root of y. Now let's do z cubed, the square root of z cubed. So the square root of z cubed. I can simplify this because the exponent is greater than or equal to the index. But it's not an easy one because 3 is not divisible by 2. So we got to rewrite it. So what's the largest whole number less than 3 that's divisible by 2? The answer is 2. So z squared, square root of z. Square root of z squared is z. So this becomes z square root of z. That's what this is. So that's going to be z square root of z. Okay, now don't leave your answer like this because you know I can write the square root of y and the square root of z as one square root. And I also know that 8 times 3 is 24. So I get this now. I get 24 x y squared z. 24 x y squared z. And then the square root of y z. And that's your answer. Okay, we have. Let me do one more, just to uh, do one where we had those variables on the outside, just to make sure you understand a little bit better. So this is going to be number 12. So negative 5n squared cube root of 128 m to the fourth n to the 11th. Okay, so again, we have that variable expression on the outside, that variable factors. So it helps if you cover it up for right now. So let's just look at this. I'm going to rewrite this piece over. So the cube root of 128 times the cube root of m to the fourth times the cube root of n to the 11th. So that's what this is. This is this. Okay, so let's talk about the cube root of 128. So remember your perfect cubes. It helps if you use the largest. So let's look at 8. 8's a perfect cube. So let's see if this is divisible by 8. So 128 divided by 8 equals 16. Okay? All right. Now, remember though, look at that 16. Is there another perfect cube that goes into 16? You got it always helps if you use the largest, and the answer is yes. 8 goes into 16 also. So that 8 times this 8, 64. All right, so the largest perfect cube that goes into 128 is 64. So this becomes the cube root of 64 times the cube root of 128 divided by 64 is 2. Okay, and then the cube root of m to the fourth. I can simplify that, but it's not an easy one because 4 is not divisible by 3. So what's the largest what's the largest whole number less than 4 that's divisible by 3? The answer is 3. So it'll be the cube root of m cubed times the cube root of m. Okay. Now over here, m is not divisible by 3. So what's the largest whole number less than 11 that's divisible by 3? It is not 10, but it is what? 9. So there's a cube root of n to the ninth times the cube root of n. Now be careful, make sure you use the right one. 9 plus 2 is 11. Okay, now let's simplify each of these. The cube root of 64, what times itself 4 times the 64? The answer is 4. Okay, cube root of 64 is 4. 4 times 4 times 4 is 64. I cannot simplify the cube root of 2, so I'm going to rewrite it. I can simplify the cube root of m cubed because that's an easy one. 3 is 3 is divisible by 3, so that's just m. I cannot simplify this. Rewrite it. 9 is divisible by 3, so that's going to be n cubed. I cannot simplify this because 2 is less than 3, so just rewrite it. Okay, now ask yourself, underline which ones are which one are cube roots? This one, this one, this one. So I'm going to write those three things I've underlined as one cube root. So all this other stuff, all these other factors, I'm going to put in front. So it'll be 4mn cubed times the cube root of 2mn. That goes here now. Okay? So that goes here. Okay, so I'm going to take this piece off now. I'm going to rewrite this. So negative 5n squared times this 4mn cubed times the cube root of 2mn. Don't leave the answer like this because I need for you to see that negative 5 times 4 is negative 20. N squared times n cubed. When you multiply like bases, you add exponents. 2 plus 3 is 5. And then times m, and then rewrite the cube root. 2mn. And we tend to put these in alphabetical order, so if you want to put the m in front of the n, you can. And that's it. Okay? I did quite a few problems where you had to simplify. If I can find the original page. So we did quite a few problems where you had to simplify radicals that was not as easy as what we did last week. Okay? All right, so I'm going to go ahead and end this part.